We are in Chapter 6, Section 6. Chapter 6 is numeration systems and number theory. So far we've talked about Egyptian numbers, Roman numbers, Babylonian numbers, Mayan numbers. Remember, Babylonian was in base 60, Mayan was in base 20, and it had some 18s thrown in there. We also talked about some computer bases, so that's base 2 called binary, base 16 called hexadecimal. There's also base 8 called octal, which is just a shorter version of the hexadecimal and binary, just a little bit different. But we're going to focus on binary and hexadecimal, just to review. And then in 6.5, we talked about how to deal with numbers that had divisors and factors and how to find the prime factorization of numbers. Other topics for number theory. Again, number theory is a very important branch of mathematics, so that's why we're kind of covering it and touching on it. This stuff is just really fun, but it seems really theoretical, so it's okay if you're struggling with that a little bit. Remember, on the exam you will get to have a formula sheet, and it's going to be open book and open note, so you don't have to worry about memorizing stuff. You can always look it up, but you want to make sure that you can get through it relatively quickly, so you're not working on the test for hours and hours and hours. Okay, so first thing we're going to talk about is one in the world is a proper factor. Now, the ancient Greek mathematicians personified the natural numbers, so they thought an odd number was male and an even number was female. Just a different way to look at numbers. They also had this concept of a proper factor, and then they used to break it into, once we know things about the proper factors, there's perfect, deficient, and abundant numbers based off of their factors. So the proper factors of natural numbers consist natural number factors of the number other than the number itself. Okay, so let's jump down to these examples. So if we consider 6 our factors, we're 1 and 6 because 1 times 6 gives us 6, and then we had 2 and 3 because 2 times 3 gives us 6. But the proper factors would be 1, 2, and 3, because again it's all the factors other than the number itself. So I'm going to put a brief pause here. I want you to try to find the factors of 20, and then unpause the video when you're ready. Alright, now that you've had a chance to do it, we're going to run through it quick. So just plain factors, what we're used to here. We have 1 and 20, 2 and 10, 4 and 5. But the proper factors would only be 1, 2, 10, 4, and 5. And again, that's because it's all the numbers except that number itself. Okay, so 25 is a little bit different because there aren't quite as many factors. This one's going to look weird, and that's because it's a square of a prime. So here our factors would be 1 and 25, and then 5 in itself, but we're only going to list the 5 once because it's already in the list, so we don't need to repeat it. Okay, so then here are your proper factors would just be 1 and 5. So that list is a little bit different, but again, that's because it's the square of a prime number. Okay. Now the 3 types of numbers that we talk about here are the perfect, the deficient, and the abundant number. So a perfect number is equal to the sum of its proper factors. So this one's the perfect number. Is equal to the sum of the proper factors. Okay. If a number is greater than the sum of its proper factors, then the number is deficient. Okay, so the number is smaller. Or sorry, the sum is smaller than the number. So sum smaller than number. An abundant number has the sum bigger, right? So the number itself is smaller. Okay, so the sum is bigger than the number. So I'm just rewording these because the way it's worded is a little strange. Okay, so this is just using less mathy words. So this one would be called abundant. Abundant. So you have perfect, deficient, and abundant. So we're going to look at these examples that we already have the proper factors for ready to go. And we're going to figure out if they are perfect, deficient, or abundant. Okay, so we're just going to add up the proper factors of each of these. Okay, and then we'll make our choice. So looking at number 6, we said our proper factors were 1, 2, and 3. So we go 1 plus 2 plus 3. 1 plus 2 gives us 3 plus 3 gives us 6. That's the same. So here we have the same as the number. So that means that it's perfect. Okay, so 6 is a perfect number. Okay, so let's look at the factors of 20. So here we have 1 plus 2 plus 10 plus 4 plus 5. So when we add those up, 1 plus 2 gives us 3 plus 10 is 13. It's supposed to be 22. That would definitely change our answer here. And 22 is bigger than the number itself. Okay, so here the sum is bigger. So going up here, when the sum is bigger, it is abundant. So then 20 is an abundant number. Okay, and then when we do the next set of factors, okay, here our proper factors were only 1 and 5, so we go 1 plus 5, that gives us 6. Here our sum is smaller, so that means 25 is a deficient number. Okay, it's easy to get the deficient and abundant mixed up. Again, it depends if the sum is bigger. If the sum is bigger, it's abundant. If the sum is smaller, it's deficient. Okay, think about it that way, you won't mess it up. Okay, now there's other things that we could talk about in number theory, but I'm going to stop here for a moment to give you a breath and maybe do some practice problems, and then we'll come back and talk about Mersenne.